Hi, this is Basic Concepts of Chemical Bonding. Continued. It is part 3 by Mindy Bedrosian. There's another part to come as well. All right, we are looking at resonance. Resonance is when more than one valid Lewis structure exists. So how do you know if there might be a resonating structure? We're going to take a look at how you would decide if one exists, even if one is valid. Please note in the textbook there are a few odd models such as NO and NO2 that are exceptions. Take a look at them and learn them, please. All right, when a possible resonating structure exists, we have to determine formal charge. This involves the difference between the number of valence electrons on the free atom and the number of valence electrons assigned to the atom in the molecule. So when it's part of a molecule, it is different. It's called formal charge. So how do we figure it all out? The rules, they're hard. So A, you might want to copy this down, maybe not. Take the sum of the lone pair of electrons and half the shared electrons. This is the number of valence electrons assigned to the atom in the molecule when it's part of a molecule. Subtract the number of assigned electrons from the number of valence electrons on the free neutral atom, one that's not part of a molecule, to obtain the formal charge. That is B. For C, the sum, I know it's crazy, the sum of the formal charges of all atoms must equal the overall charge on that species. We're going to do an example. And D, this will be in the next part, part 4. If non-equivalent Lewis structures exist, then those with formal charges closest to 0 best describe the bonding. Uh-oh. Somebody's head is getting exploded. I'm sure you feel that way. Do you feel that way? Don't panic, please. We're going to do an example, and it will be way easier if we do an example. And here's a cool dude. He's cool with that. All right, I'm going to ask you to pause and copy this down. So pause this so you have it on your paper so you can refer to it. This is sulfate with a -2 charge. So let's figure out the formal charge. First, we're going to do oxygen. So the valence electrons on each oxygen, this is how you determine, equals 6, which are the lone pairs of electrons around each oxygen, plus 1/2, and this number is going to be 2, of the shared electrons. So it shares 2 electrons. So it's 6 plus 1/2 of 2, and you can figure that that equals 7. That's the first step. Second step is the formal charge on the oxygen. And for this one, 6 is referring to the valence electrons on a free oxygen atom. Just from the periodic table this is from. It has 6 valence electrons. Minus what you just got up there, that's 7. And this will equal the formal charge, which is a -1. So each oxygen's formal charge over here is a -1 for each oxygen. Now let's do sulfur. If you look at your picture, you will see for the sulfur atom, there are no lone pairs of electrons on the sulfate, and 8 electrons are shared with the oxygens. Take a look at your picture. It has no lone pairs. So let's go through the steps again. Valence electrons on each sulfur in this molecule is 0. There are no lone pairs of electrons on it. Plus 1/2 of the shared electrons. How many are those? 8. It is sharing 8 electrons. So what does that come out to be? This is 4. Now for the second step. So the formal charge on a sulfur will be the valence electrons on a free sulfur. If you look at valence electrons from the periodic table on sulfur, it has 6 valence electrons on a free atom from the periodic table, minus the number you just got up above. So 6 minus 4, what does that equal? 2. This means that the formal charge on sulfur is a 2. Just pointing out, when it's talking about lone pairs of electrons, you can see that they're not shared. And a reminder to all of you that a line on a Lewis structure means it is a shared pair of electrons. That's 2 electrons there in a pair. So I found a googly monster, googly-eyed. And the question here is, when you look at it, there are 4 oxygens with a -1 charge each, and 1 sulfur with a 2 positive charge. So what is the overall charge on this species? That was D from up above. What is it? You should be able to come up with it. And it is a -2. So that matches the overall charge on sulfate. It's a -2. Now, we haven't talked about resonating structures. There may be another way to write sulfate. That is in the next part.